chapter 5.5 is the substitution rule. Now, what is the substitution rule? Substitution rule is basically a method of finding the antiderivative. It's a strategy. And it is basically to go against when you use the chain rule in finding the derivative. So I would call it the anti-chain rule. And when did we use the chain rule? Why did we need the chain rule? The chain rule was actually used for composite functions. And so what did it look like? So for example, when we had something like f of x is equal to the square root of 1 plus x squared, and we had to find the derivative. We had to find the derivative of this outside function, which was actually a power function. So I brought down the 1/2, kept the inside, right, and then took the derivative of this inside right here and multiplied it by 2x. So that means here that the derivative of this inside function has to exist here on the outside. Right? So one more time, the derivative of the inside function, so when you have a composite function like f of g of x, the derivative of this inside function has to exist on the outside. So now if you take a look over here, we are going to apply the substitution rule. And when you take a look at this first example, we see that here you have the inside function of x to the 4th plus 2. The derivative of which is 4x cubed. And the x cubed is out here, which will make it ideal to use the substitution rule. Now, when we use the substitution rule, to make it a little more rigid, formulaic, I should say, we can set u equal to this inside function. And again, you have to kind of look ahead to make sure that the derivative of that inside function actually exists on the outside. So in our case here, we're going to set u equal to x to the 4th plus 2. Right? So we are going to get over here cosine, instead of cosine of x to the 4th plus 2, we are going to get cosine of u. Now I have to do something with this x cubed and this dx. I have to translate it to be in terms of u. So I'm going to take the derivative of this u with respect to x, and I get 4x cubed. Well, I want to replace x cubed dx, so du is going to be, I'm going to multiply both sides by dx, and I get 4x cubed dx. Now right here, I can replace it, x cubed dx is actually equal to 1/4 of du. So this x cubed dx is going to be 1/4 of du. We make that substitution right there. And now this integration becomes really easy, this antiderivative. So when we take the antiderivative, what is the constant I can just pull out? The antiderivative of cosine u is sine u plus c, right? And sine u, the derivative of sine u, just a quick check, the derivative of sine u is positive cosine u, so we did good. And then, of course, our original problem, there was no u in this original problem here, so we need to replace this u back with what, in terms of x. So I get 1/4 sine of x to the 4th plus 2, plus that c. Now this constant might not be the same as this constant, if we're going to change variables, but either way, it's still just a constant. So that's the end of that. Next example, we have the antiderivative of tangent x. Now, if you go through and think about the derivative of sine x, the derivative of cosine x, secant squared x, the derivative of tangent x doesn't exist in one fell swoop. However, we can rewrite this to be sine x over cosine x. And now what you notice is that the derivative of sine x is cosine x, and the derivative of cosine x is sine x. So we can use a substitution in this case as well. What are we going to use? Well, if I use u is equal to sine x, then the derivative of u with respect to x, which I'm going to multiply to the other side, is going to be cosine x. So I need cosine x times dx to be in the numerator here, which here the cosine x is actually in the denominator. So this would be the wrong substitution. If you try the other one, the reason why I like u being cosine x is because the derivative of u with respect to x, I'm going to multiply again both sides by dx, I get negative sine x. Now, negative sine x, the product of negative sine x dx exists here, this way. So what does that give me? Well, I substituted cosine x for u, and then negative sine x dx, so negative du is equal to sine x dx, is going to be, so du, the negative over here. Sine x dx will be negative du. And from here, you can take the antiderivative. Now, this is one simple antiderivative, where the antiderivative of 1 over u is negative natural log of u plus c. And of course, in our original problem, we had no u, so we are just going to replace u back with cosine of x plus c. And this would be our answer. What about this one? So again, when we want to use substitution, we have the derivative of the inside function must exist here on the outside. And that is the only substitution that you want to make. So u is going to be equal to 1 plus x squared. Even though it looks like the derivative is actually 2x, and it looks like we have a little more than x over here on the outside. But let's take a look at what happens. So I'm going to take the derivative of u with respect to x, and multiply that dx to the other side. I get 2x dx. When I make that substitution, I get square root of u, right? And it looks like x dx will be du 1/2 du. So one of these x's, so I get x times x to the 4th dx. So right here, I'm going to make this x times dx is 1/2 du. X dx, I'm going to change into 1/2 du. But I still have this x to the 4th right here. And I want to change all of these to u form. Now, if you look at our original substitution here, it looks like x squared is going to equal to u minus 1. X to the 4th is equal to u minus 1 over u squared. I squared both sides. Now, in this case, what does that give me? I have the square root of u du times x to the 4th, which is u minus 1 over u squared. And if you recognize here, this should actually, I can make it into a power function, right? So I'm going to take u to the 1/2 here. I'm going to multiply out my u minus 1 squared. So I get u squared minus 2u minus 1. And then du is here on the outside. What I get, I'm going to multiply this in. I'm going to add those exponents, so u to the 5/2 minus 2u to the 1/2 minus u to the 1/2, oh sorry, u to the 3/2 du. I get 1/2, and then I'm going to start integrating from here. It is nothing but a bunch of power functions. U to the, I'm going to add 1, divide by the exponent, minus 2 add 1, divide by the exponent, add 1, divide by the exponent. I'm going to simplify, let's see what I get. So the 1/2, yeah, let's cancel all of these 1/2s. So I get u to the 7/2 over 7 minus 2/5, u to the 5/2 minus u plus c, u to the 3/2 over 3 plus c. And then, of course, there is no u in the original problem, so we must replace all the u's with 1 plus x squared. So I get 1 plus x squared to the 7 halves over 7 minus 2/5, 1 plus x squared to the 5 halves minus 1 plus x squared to the 3 halves over 3 plus c. And that does it. Sorry about the sound quality. My technology was not working that well. I hope this was okay. Bye.